Okay, this example problem is similar to problem number 2 in chapter 13. And in this problem, they're asking us to calculate a digester loading rate in pounds of volatile solids per day per cubic foot. So, as we've mentioned several times before in the class, whenever you see that word per, that is telling us that we're going to have a division problem to get to the final answer. And in this case, we're going to set the problem up like this. Pounds of volatile solids divided by cubic feet. So what information do we need to calculate pounds of volatile solids per day? We just calculated this in problem number 1. We have gallons per day of sludge. We're given the percent total solids and the percent volatile solids. So with that information, we can calculate the pounds of volatile solids per day. And then we are given the diameter of the digester and the depth in feet, so that will allow us to calculate the volume of the digester in cubic feet. So let's go ahead and calculate this out. We're going to start with pounds of volatile solids. So that equation is going to look like this. 20,000 gallons per day. Again, we're not given specific gravity, so we'll assume that the specific gravity is 1, or that the sludge has an equivalent mass to water. So 20,000 gallons per day times 8.34 pounds per gallon times 3.9 or 0.039, 3.9% solids to get our total solids content. And then out of those total solids, 78% are volatile, so we also need to multiply this by 0.78. So let's go ahead and multiply this out. 20,000 gallons times 8.34 pounds in a gallon gives us 166,800 pounds times 0.039 gives us total solids of 6,505 pounds, and out of those 6,505 pounds, only 78% of that is volatile, so times 0.78 gets us to 5,074 pounds of volatile solids. Now to calculate cubic feet, I'm going to use the radius. So radius is 1/2 the diameter. So pi times the radius squared. So radius squared would be 30 feet times 30 feet times pi gets us to the surface area, and then times depth is going to give us the volume in cubic feet. So let's multiply this out. 30 times 30 times 3.14 times 15 would give us 42,390 cubic feet. And now we can do our final division problem to get pounds per day per cubic foot. So 5,074 pounds per day per, or divided by 42,390 cubic feet. And we divide that out. 5,074 divided by 42,390 equals just about 0.12. So 0.12 pounds per day per cubic foot. So that is how you do that problem.